Hey guys, welcome to my channel. So today we'll be discussing about Spark UI. That's a Spark UI tab in Databricks. And before we start the session, a brief introduction about myself. My name is Lokesh, and I work as a data engineer as well as data architect in my current role and capacity. So if you want to reach out to me, or if you have any questions related to topics around Azure data engineering, you can reach out to me on LinkedIn. So I've been working with Databricks for past 1.5 years, and it's been a roller coaster ride. I think I've learned quite a bit, and if you are into any technology, any tool, one of the important parts of that tool and technologies is you need to know how to monitor the workload, especially if you're working in the uh, data projects. You have to monitor how the jobs run, how the execution takes place, and every tool and technology will provide you various UIs where you can check and look at the performance so that you can take appropriate actions. So that is the similar concept with Spark UI. It gives you various screens where you can monitor the jobs that run in Databricks, as well as you can get to know how your workload gets distributed, because at the end of the day Databricks works on distributed uh, concepts. So let's look into that, and with that I'll share my screen. I think I'm already sharing my screen, so let me open up the tab. Now we have already uh, ran the job, and we will straight away dive into the UI tab, Spark UI tab. For that, first you have to go into the compute tab here, or a compute page, where you will be able to see all of the clusters that have been provisioned or are active or non-active. So you can see here we are using Lokesh Hummus cluster, and we'll click on that. After that, let me just zoom in a bit. You have to go to the Spark UI tab, and that is where you will be able to monitor what is going on underneath. And one of the important factors or facts I would say to notice here is that as far as Spark is concerned, you have jobs at the topmost hierarchy. Under jobs, you will have stages. Stages are executed sequentially, and then you have tasks inside the stages. So you always have to understand this terminology or the hierarchy. Now, as I said, I've already ran one job or ran a notebook, and we'll see different tabs with respect to how the notebook was run. So, and just to give you a background or a context, I was performing structure streaming. And we don't have to go into details of what the notebook does, but we have to focus more on connecting the dots on how you can relate all of these tabs with the notebook that you've just run. Again, this will make sense if you've already worked with Databricks. If you're not new to Databricks, all of the things or the terminologies that I'm using, you might not be able to relate to that. So make sure that you have the basics of Databricks first before you watch this video. So first of all, let's explore the SQL/Dataframe tab, and the main usage of this is it will give you the list of tasks. I'll have to be very careful with the terminology that I use. It will give you the list of tasks, or you can say list of the code snippets where SQL API is involved or Dataframe API is involved. Again, I'll repeat, it will give you a list of operations. Yeah, I think operations would be a right terminology to use, because it's not related to Spark, any of the Spark terminologies. So it will give you a list of operations or code snippets where either the SQL API is involved or DataFrame API is involved. And let us take a deeper dive into it and try to understand more. So you can see here that it has listed down all the operations or code snippets where either SQL is involved or a DataFrame API is involved. Now let's reconcile with the notebook that we have executed. So again, I'll give you a background or a context of what we have executed. We have executed these two notebooks. This is the parent notebook, and the very first that you see here, where I'm hovering my mouse on, is the child notebook. So let's open the parent notebook and let's try to see whether this information is correct or not. So it first says SQL at drive local, and by the way, you can see here that the job started at 8:25 a.m. This is UTC time, and right now it is 2:08, so roughly 5.5 hours before the current time. So it says SQL at driver local Scala. So we'll have to see this notebook and see where we can find the SQL. And as you scroll down, and we also have to see whether this was executed sequentially or not. Just ignore me. I think we have to start it from this, say, job number 4. Sorry, the operation number 4, because I have been running this job in an iterative fashion, and these previous runs we got some error, and that's why you have to ignore that. So assume that it started at 8:26. Now how do we know that this is correct? Whatever I'm saying, it is correct, because I'm saying that you have to ignore these previous 4 options. So let's see when the job was started. You're getting the screen because the cluster has been terminated, because we had set up the idle time to 10 minutes. If there is no activity within 10 minutes, the cluster would be terminated. So that is what you saw there. And this particular tab will give you all the jobs that have been executed. So you can see here the job number 0, it started at 8:26:02, and that's why our assumption or whatever I was saying is correct. So we have to we have to take all those operations that started at 8:26, and we have to ignore the ones that are before that, because as I said, this was I was performing some iterative things, so you can ignore that. So it says this code snippet talks about data frame. So let's see whether we encountered that or not. So this is our parent notebook. You can see here there are a bunch of import options. Then you have a function defined, you also have a class defined, you have another function defined or a method defined, and this is where you see we are reading a CSV file that ultimately goes into a data frame. So that's why you see here the first one is for data frame. The second one is for SQL, I would say. So let's say, see here, and if you scroll down, you will see this command. This command is actually responsible for creating a temp view, which will be used for SQL API, and that's why you see it here. Then you have a SQL query. Just beneath that, you are able to see a SQL query. Again, SQL API is involved, and that's why you are able to see here. And then again, you have couple of SQL APIs. So here, after this one, we don't see any data frame or SQL API. It straight away takes us to this child notebook. So let's go into the child notebook, and once it opens up, again you see here there are some variables that are being declared, and then again some variables that are being declared. Keep scrolling down. You don't these are functions or methods. You don't see an data frame API or a SQL API. Yes, you are able to see a SQL API here. This is one, and there is another one SQL API here. So that's why you see here two SQL APIs. And if you scroll down, this is basically a function, and the function is being called here connect to Cosmos. So if you see here, connect to Cosmos is nothing but your function, and inside this function you don't have any either a SQL API or a data frame API, so that is you will not see that one in the SQL/data frame tab. But at the same time you have these two functions, create Cosmos DB, and if you scroll up you will have create Cosmos DB, right? And then that's why you see here connect to target database twice. See, connect to target database, because just try to break it down again. You have two SQL APIs followed by two SQL APIs again. The first two SQL APIs are because you have defined a method and that is being compiled, and the other two APIs that you see here is basically when you are calling that function. So if you scroll up, you see here, you see this SQL API. I hope I am accurate while explaining this, but you can comment below if you find any deviations from what is expected to be shown here. So then we see two more SQL APIs, and why is that? Let's see here. So after this we are calling another notebook. Yeah, I think I forgot to tell about this. So this is again you can see a grandchild notebook. So we have three levels: parent, then child, and then grandchild. And here if you scroll down, you have a function, that's why a SQL API, and then you are using spark.sql, two SQL APIs. Again you see two SQL references here, and then obviously once you have a function you will call that function as well. So you have this one, create threshold throughput control table, and you see here we are calling the function, and that's why you see connect to source database for throughput. Let's go back to the child notebook, not the parent notebook. So after this one you have this structure streaming. Structure streaming is based on data frame API, so that's why you see this popping up here, or this present here. So this is how you will be able to break it down and see what's going on in SQL/data frame tab. Let's open one of this and see what you will find beneath it. So you will find DAG, which actually stands for directed acyclic graph. In this case, since this is part of structured APIs, and most of the occasions we are either creating a table or doing some declarative or initiating things, so that's why you don't see a detailed DAG diagram, you only see this one. And then you can see here SQL data frame properties. So this will give you only those operations that are part of, or that either use a SQL API or a data frame API. So I hope this makes sense. So let's come out of it. Maybe let's try to open one more to see if we have a good diagram to show. Yeah, I think this one might show some diagram, because yeah, you are querying something. So you can see here this particular piece of code is actually first scanning the CSV, then there is a filter operation, and it's ultimately collecting the results and showing it on the window or the console. So this is how you will be able to navigate or use the SQL/Dataframe tab. I am not going to show or I'm going to skip the structured streaming tab, because that will add more confusions. But basically this will give you all the structured streaming queries that have been run in the recent past. So as I told you in the beginning that we are using structured streaming for this particular demo, so that's why you see it here. You'll see the average input per second, average process per second, which is nothing but your rows that have been processed per second, and the status and the name of that particular query. Now we go on to the first tab, which talks about jobs. Now we have to understand one important concept with respect to Spark execution, is that you have two different kind of operations. One is transformations, and the other one is actions. So the job is triggered only when you have an action going on. In case of transformations, those are lazily evaluated either through actions or through some other means, but mostly through actions. So we see only 4 jobs here, and again let's try to understand why we see only 4 jobs. So we have to see at various points what are the actions. So if you go into the parent notebook here, the first job actually is while we are reading a CSV. So it says that this job is triggered by an action, which is CSV at command this. So you can see in the parent notebook, let me just zoom it a bit, and we are reading a CSV file here, and that actually has triggered a job. And on the second occasion, you see here that there is a collect at command this. So this is again the same command, and you might see a collect here. See here, this is collect. So this also has resulted into a job. Similarly, you have 2 more jobs. So jobs will only be there when you have actions. Then inside jobs you have stages. So each of this job had one stage, and each of the stage has only one task. So this was a very pretty simple example, but you could have data manipulation transformations in other notebooks where you will have more than one task, and those tasks will be executed parallelly on different executors. Executors are nothing but your workers, so we will see that again. Then you have a storage tab where you can find information about the data that has been cached. Since in this case the job was terminated, the cluster was terminated, and all the caching memory was cleared out, so that's why you don't see anything here. Then you have an environment tab. In the environment tab you will see a lot of configuration details about your Spark job and cluster. Then we finally come to the executors. So as this is a distributed system, so there will be more than one machine doing the job for us. In this particular case we only had to use one executor, and that one executor means there was one machine in the cluster that was responsible for doing the job or executing the job, and this particular executor actually completed 4 tasks from 4 different jobs. and you will find lot of other metadata information regarding the storage, memory, the task time, input, shuffle. There was no shuffle involved, shuffle right. So all that stuff will be available here. And let's look at the configuration for this particular cluster. So you can see here the minimum workers is 2 and max is 8, but the job ended up the whole execution ended up using only one worker or one executor. And yeah, this is how you can connect the dots. So I hope this was useful. I hope this gave you more clarity on Spark UI tab. So I'll explore more on this, and if you already have had similar experience with Spark UI, and if you think I might not have explained a particular tab in with accurate details, feel free to comment out below, or if you have any further questions, you can always reach out to me. So thank you for that. I hope you had a good day. Thank you. Bye.